Hi guys, Miss Green here to talk about two very important factors about the moon, which are eclipses and tides. So eclipses are something that's being hidden. Celestial objects, meaning things in space, don't naturally produce their own light unless they are a star or our sun, in our case, in our solar system. So celestial objects, though, that don't produce their own light, such as planets and asteroids and moons and things of that nature, cast shadows into space. When a celestial object partly or completely comes into the shadow of another object, an eclipse occurs. So the word eclipse means to hide. So a lunar, which means the moon, an eclipse, which means to hide, would mean the moon is hidden. An eclipse does not occur at each full moon because the moon's orbit tilts of 5 degrees. Let's watch something to help this make a little bit more sense.
Like clockwork, the full moon appears every month in our sky, a sight so familiar that we often take it for granted. But about twice a year, over the course of a few hours, the full moon sports a decidedly different look. What causes this sudden change? A lunar eclipse occurs when the moon passes through the Earth's shadow, just as a solar eclipse occurs when part of the Earth passes through the moon's shadow.
Let's take a closer look at this diagram. We see that the sunlight is coming from the left-hand side. The lunar eclipse means the moon is being hidden because the moon has passed through the Earth's shadow. What phase of the moon would the moon be in, normally, during a lunar eclipse? A full moon is correct. In this diagram, our sun is on the right-hand side, but in order for the moon to be in the Earth's shadow, it would need to be in a full moon phase. Now, what phase of the moon is the moon in during a solar eclipse, when the sun is hidden from our perspective on Earth? If you said a new moon, then you're correct. If the sun is being hidden, solar eclipse, that means that something is in the way of the sun. We live on Earth and we're trying to look at the sun, but something's in the way. The only thing that could be in the way is the moon, so that would be a new moon phase.
The moon circles the Earth every month as it cycles through its phases, lining up at both full moon and new moon. So why don't eclipses happen twice a month? The reason is that the moon's orbit around the Earth is tilted relative to the Earth's orbit around the sun. Although the Earth and the moon always cast long shadows, they rarely shade each other thanks to the moon's orbital tilt. But if that's the case, why do eclipses happen at all? Throughout the year, the moon's orbital tilt remains fixed with respect to the stars, meaning that it changes with respect to the sun. About twice a year, this puts the moon in just the right position to pass through the Earth's shadow, causing a lunar eclipse. As the moon passes into the central part of the Earth's shadow, called the umbra, it darkens dramatically. Once it's entirely within the umbra, the moon appears a dim red due to sunlight scattered through the Earth's atmosphere. In fact, if you watched the eclipse from the surface of the moon, you'd see the sun set behind the entire Earth, bathing you in a warm red glow. Back home, you'll have to stay up late to watch a lunar eclipse, but if you do, you'll see the moon in rare form, and you'll catch a brief glimpse of our own planet's long shadow.
So to recap, we don't have eclipses twice a month because the moon's orbit has a tilt of 5 degrees. Only about 2 times a year does the moon's tilted orbit allow for it to get in the way of either our shadow, being a lunar eclipse, or of causing a shadow onto Earth, being a solar eclipse. Lunar eclipses happen way more often than a solar eclipse. The sun is very, very large, and in order for the sun to be hidden, then we need to have a lot of things fall right into place. This past August, there was a solar eclipse that was able to be seen from the United States. You can only really see totality, or a full solar eclipse, on very specific parts of the planet at very specific times. The moon, again, needs to be in the new moon phase in order to be in the way, blocking out the sun from a very small part of Earth. We see the umbra, which is the direct shadow, and the penumbra, which is a partial shadow. If you were anywhere in the penumbra on Earth, you would only be able to see a partial eclipse. If you were right at this exact location, directly under the umbra, then you would be able to see totality, or a full solar eclipse. These only happen once every 100 to 200 years. Living so close to the ocean, it's important that we know about the tides. The reason for the tides has to do with the effect on gravity between the Earth, the moon, and the sun that creates a cyclic rise and fall of ocean water. Now this makes sense to us. We know that the moon has to do with the tides, and we know that the tides change often. But exactly why?
If tides did not exist, the sea would just be a sphere around the Earth.
Now it's important to notice that the blue string represents the ocean around the Earth.
However, the moon is the most influential component that affects the tides. When the moon is located on this side of the Earth, it will pull the oceans toward it on both sides, leaving two humps of water on each side of the Earth. This creates two different types of tides, low tide and high tide. Each turn is approximately 6.5 hours until there is a different type of tide. As the Earth rotates, we will be seeing high tide here, low tide here, high tide here, and low tide here.
So being as there's about 6.5 hours difference from low tide to high tide, how many hours would it be from high tide to high tide?
The sun influences the tides as well. When the sun is placed here, it lowers the effect of the moon on the tides and begins to look more like this.
The image that the video just described is called a neap tide. That means that the moon is in a quarter phase or at a right angle from the sun. When the moon and the sun are at a right angle to one another, it's called a neap tide, which means moderate. So your high tides are not as high and your low tides are not as low.
Then, when the sun is in line with the moon, it moves the tides to create super high tides and super low tides because they are both pulling the water.
This is a different type of tide. When the sun and the moon are parallel to one another or in one straight line, we call this the spring tides. This will give us more extreme tides, so our high tides will be very high and our low tides will be very low. This again is due to the gravitational pull of the moon and the sun pulling the ocean water actually physically away from the Earth and then causing it to have very low tides on the sides. So again, to recap, we go through different tides every single day because Earth is rotating. So about every 6.5 hours, we see a pattern of a high tide to low tide to high tide to low tide. This pattern of hours has to do with Earth's rotation. But the tides also have to do with the phases of the moon. When the moon is in the new moon or the full moon phase, so it's aligned with the sun in a straight path, the gravitational pull of the moon on the oceans of Earth causes spring tides, higher high tides, and lower low tides. When the moon is at a quarter phase, either first quarter or third quarter, we know that the gravitational force of the sun on the moon is at a 90-degree angle. This creates neap tides, which are moderate. We'll go over this more in class. See you there.